Alright, welcome to the video on graphing exponential functions. Now, so far in this section we have looked at graphing just the basic exponential functions, or 2 to the x, or 3 to the x, or 1/2 to the x, or 1/3 to the x. Now, the reason why we're choosing 1/3, 1/2, 2, and 3 is because those are relatively easy functions to use in terms of transforming them and working with those in graphing exponential functions. We won't necessarily get into 4, 5, and 6 because they do, as you guys found out with the bean activity, is that they grow exponentially and grow rather quickly. And so we're going to stick with kind of these, but this is going to really, the rules that we use here do interpret or can be used to graph like base 4, base 5 functions. So what I've done here is I've graphed just the basic 2 to the x function that we have been working with. We just plugged in numbers and graphed it as is. Now, when we start adding and subtracting numbers to the exponent, or adding and subtracting numbers to the overall exponential function, we notice that transformations start to occur, very similar to transforming a parabola. Now, you'll notice that in this particular case that it's at plus 0, so 2 to the x plus 0, and really what that emphasizes is similar to graphing parabolas, is that causes a vertical change. Now, dealing with rational functions, we have talked about horizontal asymptotes. And in other words, you'll notice that this 2 to the x function is going to get awfully close to 0, but never actually cross 0. So this will get 1/2, then it'll get 1/4, 1/16, or 1/8, 1/16, 1/32, 1/64. But at no point are we ever going to reach 0. It's just going to get really, really, really close to 0, but never cross it. So when we get to these problems where we have a little bit of transformations, both horizontally and vertically, we first have to look at the number at the end. Okay, this number is going to tell us the vertical change or transformation. So what we're going to do is plus 2, and we're going to kind of use that horizontal asymptote that we have used in the past and kind of draw a dashed line. The reason why we're drawing a dashed line here is because this represents the line where the exponential function is not necessarily going to cross. Now, it could be down here, it could be up there, it could be a exponential decay, which is in the form of these ones. But you'll notice that either way where it goes, this thing is going to play a vital role in the graph of this function. So plus 2 is going to be a horizontal asymptote. Now, you'll notice that on this particular occasion we are not having any horizontal movement. The c up top, the x plus c, or whatever this is, I'm using some just arbitrary variable, is that c is going to have the horizontal movement, okay? And we've just talked about h, which is the vertical movement. So with exponential functions, it's a little bit different because we're gonna, instead of calling it an official vertex, we're gonna say the point at which it jumps from fractions into whole numbers, which in the case with just a basic function 2 to the x happens at 0, 1. So 0, 1. Now, at this particular breaking point, we go from whole numbers, which are our answers, to then just fractions. Okay, so this is a very important point for us because it's going to be kind of our point of emphasis moving forward. And so if we look at this, we're going to primarily look at 3x minus 2 plus 2. We already have our vertical movement. And now this minus 2 is going to change where our kind of point of changing from fractions to whole numbers occurs. So traditionally, if there was no horizontal movement, this would occur right here, one above the vertical asymptote, and then we'd have a function that looks similar to this. Okay, we'd go right up. All right. So, but in this case, we have x minus 2. Now, the same as when we did the parabolas, the x minus 2, the horizontal change is going to occur where we make that equal 0. So in other words, it's going to be move right to positive 2 instead of negative 2, positive 2, and then this is going to be our starting point. Now, what's going to happen here is, because it is a whole number, 3, where you know that it's going to be exponential growth this way. All right, and we're just going to kind of guesstimate this because we know that it's going to dip down into fractions and just get closer and closer to 2. But if we wanted to figure out what's happening here moving forward, we're going to be kind of looking at this in class, but let's just test it out. Let's plug in 3 in here just to make sure that we're on the right track. 3 minus 2 plus 2, so we have 3 to the first plus 2, which is 5. So this one would be, I plugged in 3 and I got 5. Okay, so that's going to go there. And if we do this again, let's see here. Let's just make sure we're on the right track here. Let's plug in 4. So I'm plugging in 4 into the function in some bad kind of developing my work here. We have 3 to the second plus 2, which is 9 plus 2, which is 11. And again, my work's a little bit scattered. But I plugged in 4 and I got 11. Okay? So this is a pattern we haven't really dealt with too much. But you'll notice it starts, of course, it's 1 up from the vertical asymptote. It goes up 2 over 1. Then it goes 1, 2, 3, 4, 5, 6 over 1. And you can kind of think of how this is going to do next. But again, we're going to be discussing this within class, the patterns that we kind of see in the base 3 exponential functions and the base 2 and 1/3 and 1/2. In this particular video, I'm just going to discuss the kind of starting point. We're going to starting point being the place where it moves from fractions into whole numbers. So that's the important thing we're going to be working with here. So if we look at this one, we kind of the graph gives it away a little bit, is because the horizontal asymptote is going to occur at -1. That's my first point. And then we notice that our breaking point is going to occur 1 up from the horizontal asymptote, and in this case it's back 2. And so my breaking point is going to occur here. Now I can see that it is the base is a fraction, which means we're going to have exponential decay. So I can kind of draw this going this way. And then going this way up, I'd like you to kind of test out some points. In other words, let's plug in -3. When we have 1/3 to the -3 plus 2 minus 1, we get 1/3 to the -1 minus 1, which would be, remember we talked about this, is when we have a negative exponent, we flip it, so it becomes 3 to the first power minus 1, which would be 3 minus 1, which is 2. So we plugged in -3 and we got 2. So that would be the next one. I know it's not as straight as it would look, but because of the stuff I'm using, it's not easy to draw curved lines. So if you want to find the next one, find -4. And you'll notice a pattern starts to develop here, and that's what we're going to be kind of focusing on in class. All right, so the next one real quick, just to kind of cap things off, is our horizontal asymptote is at -1. All right, our starting point, or our breaking point, I should say, occurs 1 up from the vertical asymptote and back 1. All right, so that is going to be our starting point, and you can kind of predict of how that's going to work out. And in our last one, we're just going to kind of work these rather quickly. Again, the breaking point is the hardest thing to find, okay? And then we're going to start dealing in patterns here in class this week. All right, so our final thing is it's 1 up from the vertical asymptote. I found that horizontal asymptote by -2. And then it's 1 up from there on the y-axis. And then because it's x plus 2 as the exponent, we're going to go back 2. And so again, this is the point where it goes from fractions, or close to the line, into whole numbers. And because this base is a whole number, it'll have exponential growth as opposed to decay. Now I know this video doesn't necessarily reflect on the overall graph or look of the graph, but it does give us the basis of transformations. And then we are going to talk about the look of the graph from this in class. Now it's very important that if you ever are lost and don't know how to graph a function in any case, you can simply plug in a number for x, and then you get a value for y and just graph the point. And that'll lead you in the right direction of what the graph will look like. Please come in with any questions or email me with any questions, and thank you very much.